Hi, I'm Bill Vales, and for this edition of Fun with Science, I'm going to be interviewing some of the Littleton Middle School students, the 8th graders, with their science fair projects that are going to be displayed at the upcoming Science and Engineering Fair open house. I'm really excited to interview these kids because I know in years past I've been blown away by the projects that I've seen in prior years. So let's take a look at what the kids have to offer this year. Hi, I'm here with Cameron McCloud, and we're going to go over his project for the Science and Engineering Fair. How are you, Cameron?
Good.
Good. What do you have here?
So my project was about water spouts, and it was about the water that a water spout forms. Does the temperature of that water, does it affect how large the water spout is?
Okay.
So first, to test this, what I did was I built a little chamber to replicate how a water spout normally forms. You can see a picture of that here.
I see.
Then what I would do is I would take a pot of water and I would change the temperature depending on which temperature I was testing, and I would place it at the bottom of the chamber. And then I would put some dry ice in it to make this fog so I could see the water spout. And after doing that, I would measure it and get my results.
So in your chamber here, when you put the dry ice there, could you actually see rotational?
I could, yes.
You could?
I was surprised by how clear it was.
Really?
Yes.
Yeah. Okay, so so you have your chamber.
Yes.
You got your dry ice in there, and you're putting in water at various temperatures.
Yes.
And you're measuring the speed. Oh, the diameter. Okay.
Yeah.
Okay. So what you find out?
Well, I found out that hotter water makes a larger water spout, and that's actually what I hypothesized. And I think this is because if the water is hotter, then the air around it becomes hotter, and this makes it rise faster, and it creates a large column of rising air, which creates a larger water spout.
I see. So when you say large in this context, are you referring to the diameter?
Yes.
Okay. Okay. Interesting. I see you have a lot of data to support this.
I do, yeah.
How many chambers did you have to build? Did they become saturated at some point that they were damaged?
Actually, no, because the fog that's making up the water spout is from dry ice, and dry ice is frozen carbon dioxide.
That's right.
So it's just carbon dioxide that's hitting the sides and not a lot of water vapor.
Good point. Very good. What would be the practical application of this?
Well, if you were a meteorologist and it was the right condition for one of these events, and let's say the water is cold, you would know that there's probably not going to be a large, powerful water spout forming there, because the larger the water spout, it tends to be faster. But if it's hot water, then you could say that there is a good chance there would be a dangerous, large water spout forming there, and that would be easier to predict.
I see. So the benefit in this is in the prediction.
Yes.
The prediction. Excellent. Do you have a personal interest in meteorology?
I've always been interested since I can't even remember how long I've been interested.
Okay. Okay. Great. I'm always speechless when I interview these people, and I'm starting this year out as speechless. This is excellent, Cameron. I look forward to seeing you at the show.
Thank you.
Thank you. Okay, I'm here now with Peter Holland and Will Palaya, and this project caught my eye when I first walked in. Cricket recollection. Tell me a little bit about this.
So our project was about finding how long it would take crickets to memorize a maze, and if they could memorize a maze even at all.
Okay. Why did you select crickets?
We selected crickets because they're small and we could do lots of tests with them.
Okay.
Instead of a big animal, it's harder to get lots of tests and data.
Yeah.
So as you can see here, we got a lot. We got 70 tests in total.
I see.
So that
I
really,
see.
Yeah.
And it was probably easier to convince your parents to have crickets in the house
Yes.
than Something larger.
Yes.
Okay. So tell me a little bit about what motivated you to select this project.
So we were both really interested in like biology, and we wanted to learn more about the neurology of like insects and like see if we can apply that to like how humans learn and memorize.
Interesting. So you have an interest in biology and also, I guess, brain chemistry and things like that.
Yeah.
Very interesting. Well, take me through what your hypothesis is and some of the tests that you did.
Okay, so our hypothesis was that as house crickets, the days went on that we tested the house crickets, their time going through the maze would shorten. They would get faster going through this maze. And so we tested this by painting 15 crickets. We
Okay.
painted them on their back,
Okay.
and then
So that we could identify.
With non-toxic paint.
Yeah.
Absolutely.
So that we could
I just wanted to say that.
each individual one.
Yeah.
And then we put them in a tank to keep them, and then when we took one out at a time
Yeah.
and put it right here.
So that's
This is the start of the maze.
that's the start of the maze. Okay.
And at the beginning, we tried to get the crickets to go all the way down over here.
Okay.
But that was taking like 5 minutes for them to do it. So we moved the end to here, and we placed an apple slice and some vanilla flavoring so that they would smell it and be lured to the end of the maze.
Okay. And were they?
Yes, they were actually. When we
Okay.
started using the vanilla flavoring, their times increased a lot.
I see. At any point in your testing, did you move the end up to here, or did you always keep it back here?
No, we kept the end spot the
Okay.
same.
So you didn't have a lot of patience, right? Okay. So take us through your what your findings were.
So we found that our hypothesis was supported. As the crickets, the number of days increased that we were testing them, their times went down. And as you can see here, for day 1, it was 32 seconds. For day 2, it was 27 seconds.
Let's see.
For day 3, it was 22. For 4, it was about the same.
Fractionally,
And then 5, it
yeah.
went down.
Yeah, but it consistently went down.
Yes,
Yeah.
the
Yeah,
mean,
it can-
the average went down.
Yeah. So what do you think that means? If you're a cricket, what I mean.
So we learned that so we gave the tests like a day in between. Like it was, instead of just doing all 5 tests at the same time, we did it a day apart.
Yeah.
Because they need their brains are so small that they need a long time to process information.
Mm-hmm.
So that's why we had to do it a day apart. And so I guess if you're a cricket, that means you need long periods of time to learn information.
Yeah. But it would seem to me it says also that crickets can learn.
Yes.
Yes.
Is that
They can memorize.
that they can memorize? And your lure was food.
Food innocent.
Okay.
Separately.
Did you name the crickets?
No. We didn't get that emotionally attached to them.
Oh, that was wise. Where are the crickets now?
In a better place. They're not. They
What
don't
what a
survive.
great answer.
They don't survive for that long.
Yeah.
They're not. We kept them alive for a very long
Yeah,
time.
we fed them after they were done. We didn't
Yeah.
just starve them to
Yeah,
death.
yeah. And what do you feed them normally?
Well, so we bought cricket food, and
Okay.
whenever you give them water, they normally jump in it and drown. So
Oh,
we
really?
had this gel
Yeah.
that acted like water to the crickets. So when they ate it, it quenched their thirst.
Very interesting. And I see here you had to study different sections of the brain, and
Yeah.
presumably you had to understand what those sections did. Yeah, very good. Well,
Where do you buy crickets?
yeah, where do you buy crickets?
We bought them at PetSmart. Because
Okay.
they're supposed to be crickets that you were supposed to feed to a lizard. So we saved them.
I see.
There you go. Okay, well, that's cricket recollection. Another very interesting project, and thank you guys very much.
Thank you.
Okay, I'm here now with Gianna Botelho and her project. How are you?
I'm good, how are you?
Good, good. Tell us about your project.
So my project is, what do you see, or how did the Big Five personality traits affect what a subject sees in a standard ink blot test? And what my research question was is I wanted to see how the Big Five personality traits, openness, conscientiousness, agreeableness, extroversion, and neuroticism affect what someone sees during an ink blot test. So what I had to do to start off is find out what Big Five personality was their biggest one that they represented the most. And from there, I could give them their ink blot test and then compare the results with the other members in their Big Five category.
So you actually administered an ink blot test?
Yeah, so I had the Redstone ink blot test with me, where you can see there are some examples of the ink blots in the test. And I showed them a card, and I had them write down their answer of what they saw, and then they orally told me so I could record results as well.
I see, I see. Okay, take us through some of what you did and your results.
So for my procedure, I had a table set up, and my subject and I sat across from each other. I administered the online personality test first so I could get a bearing of where they were. So this is how the setup of the test was. There were my two answer sheets, my computer, a notebook for me to record the results of the online test, and then I had my ink blots.
Okay, and these were a fixed set of questions that you came up with, or?
What my answer sheet was, it was a sheet numbered 1 through 12.
Okay.
Because there were 12 cards in the Redstone ink blot test.
I see.
So I did the online test, and then I ran through the 12 cards with them.
Okay.
And when I was coming up with my data analysis and my results, it turned out that a lot of the Big Five personality characteristics, they saw a lot of animals. And so when I was gathering results and analyzing, I had 3 groups. I had animals, inanimate objects, and vegetation. And again, animals were the most seen, and then it was inanimate objects, and vegetation was the least seen. And so then in my pie charts down here, blue is the representation for animals. And so that can be the biggest in most of them, except.
Okay. So when you say
neuroticism.
Animals are seen,
Yes.
you mean?
Like cows and chickens.
Yeah, but with
Yes.
respect to the ink blots that they came up with, or?
Yeah.
Okay, how are these ink blots generated?
So usually how an ink blot's made, they have a sheet of paper or material,
Yeah.
and they just drop maybe either black and white or different colors of ink, so they make a random pattern.
I see.
Yes, and then someone looks at it and
see.
they see an image in it.
So the images your subjects saw, the highest percentage of those were animals.
Yes.
I see. Okay.
And then sadly some of my data couldn't be accurate because I only had one subject who scored highest in neuroticism, so the results really weren't as accurate as I would have liked them to be.
I've got to ask you, what's neuroticism?
So really neuroticism it's kind of hard to explain, but it's kind of someone, I guess you could say they're kind of reserved or quiet. They might not be the best person to hang around and
Okay.
such. So.
Okay, all right. You have a lot of terms here that are going to take myself to Wikipedia, and I think some of our viewing audience to Wikipedia or a dictionary. Was your hypothesis supported?
So what my hypothesis was that the Big Five personality traits would affect what they saw, and my results were inconclusive because I generally just didn't have enough people for me to notice a big variation in what they saw. Because again, mostly animals were seen.
I see.
Yeah.
I see. So, so you need a larger sample size, and even then, it might be inconclusive as well. But
Because then you don't know what Big Five personality someone's going to be put into.
right, right. Very interesting. I look forward to seeing this at the fair. Thank you
so
very much.
Thank you.
Okay, I'm here with Kasia Cola, and how are you?
Good.
Good, good. And I see you're project, Annoying Shocks. Tell us about that.
So I took materials right here, hair, steel, paper, nylon, or wool.
Oh.
And I took them and I rubbed them with plastic wrap 10 times. And I assembled a charge detector. And I brought them, as shown right here, towards the charge detector to see which one would produce the most static electricity.
Okay.
And as shown in the results right here, hair had the most static electricity. So when the LED light turned on, I would record it with like a normal ruler, and it would be measured in millimeters. And
So when you say you record the result, this is the charge detector? Okay. And what is this here? Is
that's
this
human hair.
okay? That's human hair. So you're measuring the movement.
Yeah. So
of that?
no. So I took each material and I rubbed them with a plastic wrap 10 times.
Yes.
And I brought it towards the charge detector. It would be off.
Yeah.
So when I brought it, it would turn on, and
I
when
see.
when it turned on,
Yeah.
I would measure the distance between it. There's the antenna right there, and hair had the most steel glass. It came in last, and
I see. So you're measuring the
distance.
the distance between the material, the object. Okay. Where'd you get a charge detector?
So it's located right on the materials, home science tools, science buddies, electronic sensors kit. Those are the parts of it, and
So
I got
did you
it
build that?
So I got it online, and
Yeah.
there's this website called Science Buddies, and
Yeah.
it showed how to like assemble the charge detector.
Good for you. Good for you. How long did it take you to assemble that?
Oh, the charge detector?
Yeah.
5 minutes.
Yeah.
It didn't take that long.
Very
It's pretty cool.
interesting. Are you interested in general in electronics and electricity?
So, yeah, I like electricity.
Yeah.
I chose this project because do you like static electricity? I mean, it's kind of annoying, right?
Well, like
Yeah.
when I do that.
Yeah.
Right.
So I chose this project to like tell people which materials produce the most static electricity so that you can avoid them in the future.
Yeah. But there are some really important applications for static electricity, right?
Yeah.
Like, I think one thing is for chimney sweeping in these large coal-fired furnaces. Okay, static electricity is actually used to scrub the chimneys. So.
I didn't know that.
Yeah. You know why I know that? Because that last year's science fair, there was a young lady that had a project on static electricity and scrubbers. So I was listening to that. How long did it take you to go through all your testing and compile your results?
When I was like, how I came up with my procedure.
Yeah.
So I was either going between. So I can't measure static electricity through voltage. I can only do it through. I could do it indirectly,
Okay.
like through distance or time. I did do time, but off the chart. I used a stopwatch, and it didn't come out how I had many outliers, and it didn't.
Yeah.
So I just deleted it.
Yeah.
And I just chose the distance.
Yeah. So, I mean, that's experimentation.
Yeah.
You couldn't measure it with voltage because there wasn't enough voltage, or is it the nature of static electricity?
I didn't understand.
Well, you said that you couldn't measure the voltage.
Yeah.
Okay, why couldn't you measure the voltage?
I didn't have like a machine that could measure how much static electricity or the amount of electrons being transferred onto the
I see.
plastic wrap.
I see. So you came up with this. Very interesting. Okay, are you avoiding shocks at home?
Yeah, trying to not cause friction with my hair, yeah.
Yeah. Okay, Kasia, very nice project and a great presentation. Nice job.
Thank you.
Okay, I'm here with Faith Meegan, and this is a joint project. And perhaps you can mention your fellow.
I worked on this project with Stella Austin, Emma Tender, and it is called Concentration or Conversation, and our research question was, how does talking on the phone affect the completion time of a puzzle?
Okay, so that's to measure when you're talking to someone that's doing something else on the phone,
Yeah.
right?
Testing divided attention and multitasking.
Okay. All right, so take us through your hypothesis and how you went about things.
Okay, so we came up with our hypothesis by going through things about the lobes of the brain and the reticular activating system, which it's like in the spinal cord and in the cerebellum, and it kind of just, I have a hard time explaining this.
Well, it's brain stuff.
Yes.
I can understand.
It's complicated, and for some reason we did not seem to add a lot about that on the board.
Okay.
It kind of organizes how things are in your brain, like what inputs you take in, how many you can take in at once, which is only one, but you can try to put in more, but that's where divided attention comes in,
Okay.
and that's what we were trying to test.
Okay.
And so our hypothesis was that if someone was on the phone while doing a puzzle, it would take longer for them to complete it than people who are not on the phone.
Okay. Meaning they were distracted and they weren't as effective multitasking. Okay. How did you go about that? And tell us more.
Okay, so we got all these kids from the Russell Street over there.
Yeah.
And we had 10 subjects that were on the phone, and we asked them the questions on this paper. Things like, oh, do you have any allergies? What books do you like? We tried to distract them. They had to stay engaged in the conversation when doing this 25-piece puzzle. And we would time how long it took them to complete it, and yeah.
Okay. And what did your data show?
Well, the data showed that it did take longer to complete the puzzle when on the phone, because the mean time of not on the phone, which was 228.5 seconds, and on the phone where it took 280.4 seconds, there was 51 second difference between the two. That could have it might not be as significant as it seems on here if we had more test subjects to compare for data.
Mm-hmm.
But yeah.
Yeah. And how big was your sample size? How many test subjects did you have?
We had 20 test subjects, 10 for each test.
I see. And over what period of time were your tests administered? Were they all done the same day or a week or?
Due to the teachers being busy a lot of the time
Yeah.
when we had to take their students, we had to do it over the course of 2 weeks.
Over the course of 2 weeks, okay.
We always did a person's test on the same day, though. We never tried to split them.
I see. Did you ever get the sense with people that were tested later, that they might have been privy to some of the questions that you were asking? Did you always ask the same questions in the same order?
We did always ask the same questions in the same order, but we did tell the students before they signed the thing, if you're going to sign up, please do not disclose the questions.
Confidentiality.
Yeah.
Very good. Very good.
We can only hope they did that.
Okay. You actually do have a diagram here of the different parts of the brain, and I've interviewed a few of your classmates, and there were a few projects on the brain. Did you study neurology this year in
No, we
school?
didn't. We did not. I just have always thought how the brain worked was just so interesting. I was like, how can one small thing understand so much? I just really wanted to know more about that.
Wow. Okay. Well, Faith, very interesting project, and I'll look for this at the Science and Engineering Fair.
Thank you.
Okay, thank you very much. Hi, I'm here with Miss Affinity, and how are you?
Good, how are you?
Good, good. You're teaching 8th grade?
8th grade science.
8th grade science. I'd say you were successful again this year based on the...
We have some great projects this year.
You really do. You really do. I've actually noticed in the 3 years that we've done this now that the complexity of the projects, the subject matter seems to be increasing.
Yes and no. I think that what you got are kids who volunteered to come and be interviewed, and
Yeah.
so there are some even more complex projects
Really?
out there. Yeah, this was a great selection of kids. The projects really range from simple to very complex, and this year we do have some that are way beyond anything we've ever had before.
No kidding.
I think it's just the kids. I don't know that it's necessarily anything I'm doing. I think that maybe it's because we've had the science fair this is the 13th year, and I think kids are starting to think about it earlier, and sometimes kids email me during the summer saying, I know what I'm going to do for my 8th grade science project. This is, they want to get started with me right away. And
Yeah, yeah.
so
Well,
this year we have a bunch of very sciencey kids.
I have to believe that you're playing a role in motivating
I
the
hope so.
students. And do you find that the kids get motivated outside of the school, at home and in other areas?
Yeah, I think that for a lot of the kids, completing a science fair project shows them that they can, number one, do science, that science is not just something that you learn in a book and take a test about. It's out there, it's applicable to their lives and to things that they care about. And I spend a lot of time with them at the beginning of the year talking about possible science fair projects and getting them to think about where they can make connections. And so even as early as September, when we have class discussions, I'll say, oh, that would be an interesting science fair project. And I just start kind of, sowing the seeds early, I guess. And
Yeah.
We spend quite a few weeks before they choose a project exploring possible topics. And I talk to them about the different branches of science, because they don't certainly learn everything or even explore all the different branches of science. Like just this year, we started having electricity as part of the state standards. So actually, I guess we put it in last year, but prior to last year, we didn't have electricity in the state standards at the middle school level. This is the first year I taught weather and climate. It's the first year that it's been in the state standards. So I think I do see patterns where kids seem to be latching onto something that they did study in school, but other times they apply it to sports. There's a lot of kids who do projects with sports because
Yep.
they want to know which baseball bat is better, or we have projects with dance and which point shoe results in the greatest number of turns. Things that they're curious about with cooking. A lot of kids like to do cooking
Yeah.
projects.
Yeah. When you take a topic such as electricity or the climate, how much of your curriculum across a year, what percentage can you spend on each of those topics of time?
Well, I have certain topics that I teach, and I don't teach others. So this year I taught weather and climate. I teach genetics, evolution. I haven't gotten to physics and chemistry yet. That's coming next. So I don't teach electricity. That was in the 7th grade.
I see.
So when we start the science fair season, we do spend time in class exploring projects, and I really do try to mentor each student or group of students, if they're working with partners, about their topic, and I help them kind of explore the background research. So, so for example, Will and Peter were interested in studying the brain. So I helped them do background research on the nervous system in general, and then the nervous system of insects. We found some books. So I have a lot of books in my classroom, and then of course we have the whole internet at our disposal.
Yep.
The challenging piece is to try to find resources that are at the right level for kids. I mean, some of the kids
Yeah.
are, advanced, but they're still not able to read like graduate level
Sure.
studies. So trying to help them find resources. So we spend probably 2 or 3 weeks, not every day in class, but just over that time period doing research. I spend an entire week in class helping them to do research with books and with internet sources, and trying to help each student find background information. And then they write a research paper. and then I have them choose a research question. Some of them think they know the research question at the beginning, and then I say just keep an open mind because you don't know enough yet. And then once they've done their background research, then I say, okay, now it's time to start figuring out what your research question is and what you would be doing for an experiment or an engineering project. So we didn't have any engineering projects here today, but I have about 9, I think, this year.
Yeah. And the idea that they have to select a hypothesis and either prove it or disprove it, is there any sense of disappointment if the hypothesis isn't
Well,
proven?
I tell them, so the hypothesis is based on their background research,
Yeah.
and then they do their experiment, and I tell them that if their hypothesis is not supported, oftentimes they can learn more than if their hypothesis was supported, and they just say, oh yeah, I was right. If it doesn't support their hypothesis, if the data that they've gathered doesn't support their hypothesis, they have to think about why. And a lot of the kids, I was very proud of them, talked about the limitations in the project.
Yes.
Yeah.
Yeah.
Not enough trials, not enough
Yeah.
crickets, not enough human subjects. And that's one thing that I think is really important for them to understand, that every scientific experiment has limitations and
Yeah.
that it affects the outcome. And so it didn't support their hypothesis. It doesn't mean they were necessarily wrong, but they need more evidence. And so that's what I like to hear. I would need to have more subjects. I would need to test
Yeah.
more crickets. I would need to, try more variations in temperature.
Yeah, yeah, interesting. Of the main topics that you teach, and how many topics do you?
Well, this year I taught weather and climate for the first time, and it took a long time because it was my first time teaching it, and
Weather.
so it took up a big chunk of the fall. And then I teach genetics
Okay,
and evolution,
okay.
and then like chemistry of motion
Okay.
and some chemistry, basic
So
chemistry,
it-
but some of it was taught in earlier grades also.
So with some topics, do the kids come in with preconceived notions on various aspects of the topic more than others? Like, for instance, climate. Climate. Well, they're exposed to weather every day. Do they come in thinking, well, I know a lot about weather? And,
I don't know. Are you asking about misconceptions, perhaps, or?
well, preconceptions, whether they're misconceptions or not, that's
I would
that's
assume-
fodder for another show.
Yeah, I would assume that they do. I think
Yeah.
that if I asked them, I think they would say that they found out that weather is much more complicated than they realized, and it covered, a lot of chemistry and physics, and they learned about heat transfer and the movement of wind and how air moves from hot to cold, and I think that they realized that it's very complex. And actually, Cam, who was here earlier, he
Yes.
won the school geography bee
Oh.
and went on to the state competition. And he told me that at the state competition, he had 3 questions that he was able to answer because of our weather and climate unit. So I thought that was interesting, and he did get 3rd place in the state.
Wow.
Yeah.
Wow, that's
Yeah.
that's very impressive. I'm very
I'm sorry, I didn't really answer your
Yeah.
question, but I
No,
guess
that's
I don't
okay.
really know.
Yeah.
I would assume that they do, but I don't spend a lot of time going over their preconceptions. We talk about, like, I'm aware of certain misconceptions that I try to tease out and target,
Yeah.
like especially
Well,
about
I-
climate change and things like that.
I would think with the audience, irrespective of what age they are, you would sense pretty quickly whether someone has their own ideas about how something works. I mean, people aren't afraid, it seems, to convey what they're thinking, so I'm just wondering about that. Well, I have to say, Ms. Affinity, I'm very impressed with the caliber of the students, the projects they select, how they present themselves is just, really to your credit, to their family's credit, and certainly to their credit. So I think you're doing a
I really enjoy it. I enjoy
a
it
great
most of the
job.
time.
Yeah. Well, thank you very much, and I'll
Thank
look
you.
for you Thursday at the
Yes.
science fair. Science
And engineering fair.
Science and Engineering Fair. Okay. Well, once again, interviewing these kids leaves me absolutely speechless. I'm trying to think as I'm talking to these kids what I was doing when I was in 8th grade, and talking to these kids that are studying climate, neurology. It's really amazing what the Littleton Middle School is doing in preparing kids in some of these STEM topics. So I hope you enjoyed this show. I look forward to doing this show every year, and we'll see you next time on Fun with Science.